So with this session, we have a close look on how to identify the articulation point. So this articulation point is considered as the dangerous point or critical point in any of the network. So here I have drawn a graph for better understanding of this articulation point. You assume these are all the nodes connected with each other, or if it is in a for any kind of application, you assume these are all different cities that has been connected through roads, through highways. So if this is the case, suppose if I remove the node 4, and this 1, 2, 3, 4, 5, 6 are considered as vertices, and these are all the edges connected between them. And if suppose the node 4 has been removed, in that case we could not able to connect to the values or nodes 1, 2 and 3. Similarly, on the other side from 1, 2 and 3 we could not able to connect the values 5 and 6, which it says it has been completely disconnected into two different components or two different disjoint graphs. So now this four we call it as dangerous or critical points. And there always we won't welcome or appreciate of having articulation point or critical point or dangerous points in a network or even in any communication channel. So now let us consider this problem, and we see how what the procedure to identify this articulation point. And to avoid this articulation point, it is better to have another edge communicating between 2 and 5. Similarly, we can establish a channel between 3 and 6. So these are all the ways to resolve this issue. So now let us check the algorithm how to find this articulation point. So initially, just construct the depth first search tree using tree edges and back edges. So I'll explain what is tree edge and package. So for this graph, so here I want to construct depth first tree. So initially assume I'm starting with the starting traversal from the value 1. So from the value 1, I can proceed towards the direction on left side as the value is 2. So here the depth first tree will be constructed as like this. From 1, it has been reached the value 2, and from 2 there is a connection to 4. So from 2 there is a connection to 4. So in this manner the first tree has been constructed. And again from 4 there is a route redirected to 3. So now it has been connected to 3. And here, so now again from 3 there is a edge connecting back towards 1. But we already started the traversal from 1, and this edge I call it as back edge. So this is rerouting back to 1. So this edge again it is rerouting back to the original source, that is 1. So similarly again from 4 there is a edge connecting to value 5. So from again I am starting a edge connecting towards 5, and again from 5 to 6 there is a connection. And again you can see from 6 to 4 there is a back edge, which means again it is connecting rerouting back to the value 4. It is like a I mean it is like a cycle. So from again 6 to 4 there is a connection existing or established here. Likewise we have to construct this depth first tree using this tree edges and back edges. Now we have constructed, and this particular tree I call it as depth first search tree. And using this depth first search tree we can ascertain whether articulation points existing or not. Just by having a close look on this graph manually you can say, but for the machine to understand and to identify whether articulation point is existing, this is the better procedure to get followed. So now depth first search tree has been constructed as the first step, and as the second step, for every vertex we have to number it with two values. One value I term it as number of I, the number given for the vertex, and the other I call it as the lowest point, from where the lowest point can be reachable. So the lowest point is the one that is reachable after encountering 0 or more tree edges and possibly with one back edge. So if you check the condition here, 1 is the initial state. So the number is given as 1. Similarly, the second one to be visited is 2. So the number is given as 2. And for 4, the number is given as 3. And again, for 3, as it has been visited as the fourth vertex, the number is given as 4. But again, you can find one baggage traversing back to 1. So now this is considered as the baggage which is rerouting and visiting to the value 1. Now this one is considered as the lowest value that is reachable by all these vertices. So the lowest value for all these vertex will be 1. That is considered as the denominator here. Similarly, from 4 again there is a direction towards 5, and 5 to 6. So this is the fifth vertex that has visited. So that is a numerator here. Even for 6, it is the sixth vertex visited. So numerator is 4. Again, you can check that is a possibly package be visiting the value 4. I mean, the lowest nearest possible value reached from these vertices is 4. So that all the denominators should be 4 here. So in this case, in this manner, you have to identify or determine the number value as well as the lowest value. So once you ascertain these two values, now to check whether there is an articulation point or not, the condition given is the lowest of j. Consider j is the child of I, and this condition is valid except the root value. So now, if the low of j is greater than num of I, and if this condition is satisfied, then I is considered as the articulation point. Now, manually, we know that 4 is the articulation point. And with this condition, you can check the low of j for 5 is 4, and for even 6 is 4. And here you can check the number of 4, that is 4. I mean, the numerator here it is 4, whereas the denominator for 5 and 6 it is 4. So here it is equivalent to this value. So once this condition is satisfied, we can come to the conclusion that 4 is the articulation point and accept root. So that's why we are not considering 1 as the articulation point. Instead, we are saying that 4 is the articulation point. And likewise, for any kind of complex graphs using by or applying by this procedure, we can identify articulation points. And the way to remove this articulation point is possibly connect more edges, so that even this 4 gets failed due to any disruptions, there is a way to connect to the other side of the graph. Either the connection can be established between 2 to 5, or it can be between 3 to 6. Thank you.